Hello, did you know that according to the new biology, we are more than the sum of the parts? We are complex systems. Hello, my name is Patricia Warby, and here today on my channel, I want to review a book called Notes on Complexity by Neil Theise. I hope I've pronounced that correctly. Now, Neil is a pathologist, actually. He also works on stem cell research, and he's investigated the nature of consciousness. And in many ways, he's a great follow-on from my previous review, which was Federico Fagin's Irreducible book. And in that book, we were looking at the nature of consciousness as being more than simply the result of electrical signals. And so the qualitative difference between how we perceive things and how our nervous system creates electrical information has never been satisfactorily explained. Now, that feeling sense of something is called qualia. They are called qualia. And you can't really say that they're an emergent phenomenon. We can't explain it. There has to be another way of explaining it. And I think in many ways, this book kind of fills in a nice gap between Fagin's work and, the new quantum understanding of life, the universe, and everything. Now, the subtitle of this book, Notes on Complexity, is a scientific theory of connection, consciousness, and being, which is beautiful. And I like the fact that generally subtitles usually bring in three things. There's always three things in the subtitle, generally. I think Fagin's work, he brought in four things, which was interesting. So I've made some notes myself. So subtitle to this could be Notes on Complexity, but I jest. Let's get into it. So we learned before from Fagin's work that machines are not the same as human beings, which sounds very obvious, but there are many people, particularly with the push for AI, who are saying that AI will take over the human being experience and take over some of our previous roles. But I think there are significant differences between the kind of computational understanding of the world and how computers work with how our brains decode, if you like, a greater consciousness. After all, we have agency, we have identity, we have comprehension, we're able to intuit things. So I think it's worth considering this. And complexity theory, it refers to the self-organizing, unpredictable open systems from which life emerges in our universe, okay? So it doesn't mean complicated. Got to be really clear here. Neil was very clear in his book. What he's saying is that the whole is greater than the parts. We are not like machines, therefore. And I love this quote from early on in the book. The universe is a shimmering web of complexity that continually births and nurtures life. What a beautiful idea. We are part wholes, in other words. So he doesn't use that phrase. That's Fagin's phrase. But I think I'm going to reiterate it here because I want to kind of link these two books. And complexity theory gives us a deep connection, therefore, to our place in the larger whole, and thus is an antidote to reductionism, which is lovely. So the understanding of consciousness being more than just our awareness, but being a bigger consciousness, a big C consciousness, if you like, was something that Fagin introduced and many others have expounded upon. But what I love about this book, and it's considerably shorter than Fagin's, it's about maybe 2/3 the size, just over 200 pages, is that he has a central theory which he's very focused on delivering. And so it's not padded. The book is beautifully written. And I've included some quotes as I'm going to go through because he just knows how to write, and it's a wonderful thing because not all scientists do. As another book I'm reading at the moment is Proof, which I'll come on to next time. Okay, so he takes us through the history, which I think is lovely. The history of science is always interesting. And he's saying that he believes that complexity bridges the gap between the two main theories of our universe at the moment. Quantum mechanics, which describes things at the very small scale, and special relativity, which works at the cosmological scale. But it differs radically from those two because it can't be predicted by a set of equations, okay? Only by computer modeling, and that's significantly different. Now, it arose from the study of systems, not parts, okay? So that's another significant difference. And it really was looking at the way systems self-organize to create wholes. And it arose from fluid mechanics, the study of how fluid systems operate, and then was kind of developed further. Mandelbrot's fractal patterns, Benoit Mandelbrot, talked about him last time, developed a very simple equation which self-iterates, which creates, when it's computer modeled, these beautiful, beautiful patterns. And I really encourage you to go and Google Mandelbrot fractal and just follow some of the videos. You'll be mesmerized, quite literally. But he was looking at weather systems as examples of unpredictable, complex systems. And he was showing that mathematically, everything can be broken down into smaller and smaller nested patterns onwards to infinity, right? So a fractal does not finish, or it doesn't have a beginning or an end. It's just a set of nested things like Russian dolls, if you like. However, in nature, he found that there is a limit, okay? So blood vessels don't continually divide. The airways also are limited. River systems, stop at some point. Tree branches, fern leaves, and so on, don't continue on to infinity. So in nature, there is a natural stopping point. And so Mandelbrot, although he attempted to describe this, struggled a little to find why that was. And so despite his efforts, we can't use a Mandelbrot fractal to perfectly describe life. Now, going through the history, he talks about an early game that was developed called the Game of Life. Very interesting. I'm not going to go into that here. He raised the issue of some of the men, it's mostly men, in fact, who've worked on this through game theory and computation. Stephen Wolfram, Christopher Langton, Norman Packard, some very famous names. And he was sort of showing how the understanding has built. We often say, you build upon the shoulders of giants. You go from what somebody else has discovered and you add in new understandings and so on. So in many ways, you could say that man's knowledge is incremental and maybe fractal to some degree. He describes that complexity actually arises at the boundary between chaos and stability. That's a very important point. It's in that phase transition between those 2 points, utter chaos and perfect stability, that something magical happens. Packard, in fact, described it as the edge of chaos. And scientists have wanted for a long time to investigate biological complexity, how we became the way we are. And they've kind of seen that it's about adaptations made in response to changes in environmental conditions. That for something to be static does not allow life. Everything changes. And the biological system has to have an adaptation. So it has, to some extent, to have a computational ability. And we've seen that Michael Levin's work has really looked at that in detail. Evolution then leads to complexity. It also feeds back into, so it arises from as well. And Stuart Kauffman in the 1990s used mathematics to describe how different types of cells might arise from each other. He called it differentiation, and we might now think of it as morphogenesis. One of the central problems of biology is, how does a cell know to become one thing, a liver cell, as opposed to a kidney cell? And it seems that complexity is part of that equation, if you like. It's due to the quality of emergence, things that appear as a result of the interaction between the constituent parts. And chaos and complexity actually differ in their degree of predictability. Now, I hadn't realized that. I had thought chaos and complexity were one and the same thing, but in fact not. Complexity arises at the edge, the transition phase between chaos and stability. So the degree of predictability, think about that. So in chaos, the same starting conditions will always show a predictable outcome, according to Neil. Now, I have to say that doesn't agree with my reading of chaos theory, but maybe I've misunderstood. But there you are. That's his understanding. So, but in true complexity, you have a same starting condition. You can only say that emergence will happen, not how or when. And so in true complexity, the whole is unpredictably greater than the sum of the parts. Kind of like our lives, he says. I love that. It's just these little, the way he puts things, I think is very human. It's very thought-provoking, and it makes you think of the deeper questions, I suppose. So we're not walking in the world out there, as he says, we are interwoven with it. And that's certainly something I've been aware of myself as I've investigated this more and read some of the latest thinking on this. And it's something that you intuit as well, that the world is not separate to us, it's part of us, and we are creating it as we are living, in many ways, by our thoughts, beliefs, actions, particularly the unconscious beliefs. It is a very strong interaction with the universe in which we're embedded. So he describes 4 rules, which I'm going to go through now. 4 rules of complexity. Number 1, the more interacting parts there are, and you could call parts, they could be cells or ants or people, and the greater their diversity, the greater the complexity of the resulting system. So whether that's bodies, ant colonies, cities, cultures, or civilizations, it works at different scales. So in other words, a single cell organism is not as complex as a multicellular one, because there are more parts and more diversity in a multicellular organism. So that's rule number 1. Rule number 2, in self-organizing systems, all interactions are local. They're happening at the same level. There is no all-knowing individual or entity, or even the queen directing the participants in an ant colony. Okay, so we think obviously the queen does signal, but she's not creating the full degree of complexity. It's actually, in an ant colony, it's the pheromones that they lay down as they move around, which build a sort of a message to the other ants to act in certain ways. And so, in other words, organization always emerges from the bottom up, not from the top down. Now, I had a question, therefore, but where does that leave us with the notion of God? Bit of a big question there, because the way human beings have conceived of God, the all-knowing, all-seeing kind of God, is that they direct things from above, and that we are simply following fate or whatever it is, karma, that's kind of being directed. But actually, that really brings into question the idea that there is some overall direction that isn't actually driven by our interaction with the world. And that's much closer to how I perceive God or source or whatever you want to call it. Number 3 is that these self-organizing systems have a negative feedback loop to keep the system healthy. Now, if we think of homeostasis in the body, for instance, it's not a stuck state. If something needs to be adjusted, it's the fact that it oversteps a certain level that brings it back into balance. It's a bit like a thermostat in a heating system. And so homeostasis, probably better called allostasis because it's not static, is a feature of human tissues. So, and cancer actually is a form of positive feedback leading to uncontrolled growth. Very important understanding. So when you're looking at it from this holistic viewpoint, cancer is a failure of the system to self-regulate. And the newest cancer treatments actually are aiming to restore the negative feedback control, whether they're looking at the immune system or whatever. They're trying to bring back this self-limitation. Number 4, the final one, is that the degree of randomness is key, okay? There must be some low-level randomness or unpredictability in every living system. Too much, and there can be no self-organization. There's no greater whole. Too little, and the system is unable to adapt if the environment changes. And so no novelty arises. And this beautiful balance in the middle between not enough and too much is what he terms quenched disorder. So I thought that was an interesting term. So it's sort of limiting the disorder to a certain balance point, which allows the system to explore the adjacent possible, in Stuart Kaufman's words. All right, the things that might develop next to the current state. And so this allows new ways of being, which then create a new range of possibilities. And I think, obviously, therefore, this is part of how evolution works. Okay, it's not, it has a degree of randomness, but it is also self-directed. And that's why we can't predict what happens, okay? We can't say exactly how it's going to unfold, but we can say it will drive a new adaptation. Now, the vast majority of adaptations will not work, they won't be adaptive. But given the huge, unbelievable number of adjacent possibles, these alternative solutions, there will be a small number that will be adaptive and will be taken up and will be incorporated into the functioning of the unit that we're talking about, whether that's a cell or a molecule or a subatomic particle, okay, until such time as something no longer works, in which case we get what's called an extinction event. Now, you may have come across the term because many scientists are now saying we're facing a mass extinction event in the current setup of our world because of our ridiculous extraction of resources and unsustainable numbers. But in fact, it's part of the ongoing evolution of the universe to have these mass extinctions. If the dinosaurs hadn't died out, we probably wouldn't be in this ascendant position that we're in now. And so from here, these rejigs are part of the system which make way for new emergent forms. Now, cells also form complex systems. In fact, they're nested complex systems, as he says, because there are obviously cells within tissues, within organs, within bodies. And so if we think of that, it is in some ways, it is a fractal state. And he raises the issue that whether something looks like a thing or a phenomenon arising from things depends on your scale. And he gives the example of ants. If you viewed a colony of ants from a distance, they just look like a fluid flowing. Or starlings murmurating, just looks like this amazing shape-shifting thing in the air until you get closer and you see it's made up of tiny birds all moving in synchrony. So it does depend on your scale as to how you observe. So the question then is your body a unitary thing, or is it a phenomenon or interaction resulting from the parts? And his conclusion is it's both. All right, and this is a quantum idea that things can be neither one thing nor the other, but they can be both, and this is called complementarity. It's the same as light is now considered to be both a wave and a particle, because it can exhibit both states depending on the observer. Or you could say the microbiome. I've written a book on the microbiome. The microbiome is all the tiny microbes that live inside and on us. They live in the folds of our skin, in our eyes, ears, in our guts, hugely. And, you know, they're living organisms creating different chemicals which affect us, our brain chemistry. They drive us to eat certain foods, to think certain thoughts. Who's to say that this human form isn't actually the result of the microbes, the microbiome within us? Well, it's just another viewpoint, isn't it? And so boundaries are indistinct. So what we consider the boundary of our skin, for instance, you know, our skin is continually shedding, and air molecules, you know, and water and all sorts of other things are interacting with it. Is this a true boundary, or is it a permeable boundary? One could argue that at a cellular level, cells are always exchanging molecules between the inside and the outside. So is the cell membrane, which we've always thought of as the definitive edge, if you like, is it a boundary? And are they distinct entities, or are they part and parcel of their environment? And isn't it the result of our technology, he argues, which views them as distinct entities because of the way we study them under the microscope? We look at them and see them and believe that they are distinct things. But if we had a different way of measuring, if we had instead of a cell doctrine, as he calls it, a fluid doctrine, and we saw just the movements, or we just investigated the quantum and field interactions, then maybe we'd have a better model for certain things that we know occur. Things like extrasensory perception, for instance, or how acupuncture works, or homeopathy. We've never really been able to explain those with this defined barrier. It's in the way of our understanding, actually. And so, once again, support for the idea that bodies are not machines. They are dynamic emergent systems. And he goes on to talk about that at different scales, including the cosmic scale, and the fact James Lovelock's Gaia theory of that the Earth is one giant sort of interacting organism. And you know, I love it how he weaves all the different factors together. It's very powerful. And he says, in the quest for the theory of everything, we hit a problem in that the two current theories, that's quantum mechanics and special relativity, do not align. Well, we do know that there has been work on that. I've talked about that. Nassim Haramein has done a lot of work, as have many other people, on trying to unify physics in that sense. But in fact, he argues that both of those are an approximation only, working at either very tiny or very large scales. And in fact, particularly at large scales, it's what we perceive as being reality. But when you break it down, you can see that that's a very unusual occurrence. And quantum fluctuations arise all the time. He describes what's called the quantum foam, which is where things emerge and then disappear, and emerge and disappear back into the quantum field. And he says that throughout this sort of emergence and disappearance, energy and matter are combining in a way to create or annihilate. And so it's sort of a matter and antimatter combination. But sometimes the pairings do not annihilate, but combine, creating the matter, which then becomes self-organizing. And that's where the matter, the things that we perceive, arise. And so another direct quote from this book, which I love: we don't live inside the universe, we embody it. And that's a very deep thought. It suggests that we are the universe. We're part of what he calls the holarchy. He didn't want to use a hierarchy because that implies certain levels are above other levels. And he thinks all the levels are interwoven. And he's borrowing from the work of Arthur Koestler there. all the levels are equivalent. So that's why it's not a hierarchy. He uses the word holarchy. The final part of the book deals with the nature of consciousness. And obviously, because I've done a lot on this with Federico's book and other books, he completely agrees with those writers that neural correlates do not support brain makes mind. Okay, so the fact that we can see neural activity doesn't make the quality of what we perceive. And if we continue down that path of saying that consciousness, our own individual consciousness, small c consciousness, arises just as a result somehow of these electrical signals, that we are barking at the wrong tree, as it were. And correlation doesn't imply causation. He uses a great example that you could say sunglasses arise from it being summer, but summer doesn't cause us to wear sunglasses, you know. That's just a correlation. And, you know, this whole problem is what's called the hard problem of consciousness. And it was coined by David Chalmers in the 1970s, I think, that we can't explain the subjective experience of perception, the lived felt experience in just the way that electrical signals work. So he wonders, therefore, does consciousness of the human body derive from the aggregate consciousness of the subunits of the cells and the parts of the cell? And I think there's a great argument for that. He then goes through a great deal of history of consciousness understanding, from Platonic idealism to big C consciousness. And then he goes on to Gödel's incompleteness theorem, which I had never really, I'd heard of it, I didn't really understand it. He tries to explain it to non-mathematicians in a non-mathematical way. But basically, he showed that this incredible thinker, mathematician, showed that things can be known to be true, but not proven to be true, which smashed the whole mathematical idiom, really, which was that you could only accept things were true if you could prove them to be true. And so that leads us on to the idea that truth can only be realized through intuition and through a deeper knowing internally, a sort of metaphysical meaning from deep contemplative practice. So turning the mind inward to explore itself, that's really how the ancient thinkers understood consciousness. And we're kind of turning full circle now and coming back into that idea. And the final part of the book, which in some ways I have to say is the weakest part, to be fair, and I don't like to criticize anything because it's hard enough to write a book, I know, and to get your ideas here, but I kind of felt this was a little tacked on. He's got together with a collaborator, he says, in consciousness studies, Menas Kafatos, who's a physicist, mathematician, and cosmologist, but also, like Neil, is deep into contemplative practice, you know, meditation and so on. And they kind of chose 4 different methods of investigation: Buddhism, Kabbalah, the Jewish tradition. There was another one, Kashmiri Saivism, which I'd never heard of, and Advaita Vedanta, the Hindu tradition, which I had heard of. And he sort of goes through and describes each tradition and how it kind of maps to this understanding of consciousness, which, you know, is a noble idea. I just felt it was it just needed a bit more exposition towards the end, and it felt like it finished too early in some ways. One of the most powerful parts of the book is the afterword, actually. He reveals some of his own struggles in his own life, and, you know, and how profoundly this has changed his life, this understanding. And so overall, I think this is a brilliant book. It's a lot easier to read than Federico's. I could finish that in a weekend quite comfortably. I have gone back and read it again to make the notes for today. I loved it. So I highly recommended. The next book review I know which I'm going to do because I know what I'm reading at the moment is all about plasma being the nature of the universe. So you can kind of see the theme I'm developing here. And if any of you are interested in some of these ideas and you'd perhaps like to investigate your deeper consciousness, your unconscious process, then please, you can find me on alchemytherapies.co.uk. And I look forward to hearing from you. Take care. Bye-bye.